Hey everybody, Brian here from highschoolmathcourses.com. Today we'll be looking at a few examples from the handout discussing limits of polynomial functions. Now, put simply, the way to evaluate the limit of a polynomial function is just to evaluate the function at the value being approached. So let's look at a few examples. In this first example, we have the limit as x approaches 1 of the function 3. Well, regardless of how close from values less than 1 or values greater than 1 we get to 3, the value of the function is always 3. And by the theorem, we can just evaluate the function at 1. So the function is 3, therefore, when you evaluate it at any point, it would be 3. So the limit is therefore 3. And as you can see from the table and the graph on the right, as we get closer and closer to 1 from values less than 1 and above 1, the function remains 3, and that supports our conclusion that the limit was 3. Let's look at a little bit more interesting example. Here we have the limit of a linear function, in this case 2z minus 4. And again, the variable is approaching 1. The limit as z approaches 1. Well, by the theorem, all we have to do is evaluate the function at the value being approached. So in this case, we just substitute 1 as the value for z, and we get 2 times 1 minus 4. And then the end result is we conclude that the limit is negative 2. And as you can see from the table and also the graphic on the right, as we approach 1 from values less than 1 and greater than 1, the limit is determined to be negative 2, which this supports our original conclusion. Let's look at a little bit more interesting example. Here we have a cubic function. So we have the cubic function, which is a polynomial function. So in this case, z is approaching negative 2. The variable is approaching negative 2. So we evaluate the function at when z is equal to negative 2, and this will be the limit of the polynomial function. So we plug in negative 2 for z, we evaluate, and we determine that the limit is 0. As we can see from the table and also from the graphic on the right, as we approach negative 2, both from values less than negative 2 and greater than negative 2, as we get closer and closer to negative 2, we see that the limit is 0. The function is approaching 0. Let's look at one seemingly complicated but relatively straightforward final example. In this final example, we have a polynomial function of order 99. So the highest term is raised to the 99th power. This looks very complicated at first glance, but because we know that in order to evaluate a polynomial function, you simply have to plug in the value being approached. So in this case, we have the variable y is approaching 0. So we can evaluate the polynomial when y is equal to 0, and that will be the limit of the function as y approaches 0. So when we plug in 0 and evaluate, we get that the limit is 1. As we can see from the table, as we approach 0 and get closer and closer to 0 from below 0, and closer to 0 as we approach from above 0, the values continue to approach 1. And as we can see on the graph on the right, as we approach the y value of 0, which is our independent variable, as we approach the y value of 0, the graph, or the function value, continues to approach 1, which both of these support our original conclusion that the limit is indeed 1. If you'd like this handout or additional information, please visit highschoolmathcourses.com. Thank you.